Hello friends, welcome to Quality Munch, your go-to place for everything about quality. I am Jitendranath, your host, and I am so glad you are watching this video. Today, we have a very interesting and fascinating topic to explore. Can you guess what it is? Well, our topic for today is the basics of Six Sigma. Before we start, I have a small request. If this video add value to you, please give it a thumbs up, share it with your friends, and consider subscribing to Quality Munch. Your support means the world to me and it motivates me to bring you more quality-centric content. Six Sigma is a discipline and data-driven approach, like a structured method or toolkit that businesses use to make their processes work better. It's all about improving things by reducing mistakes, minimizing variation, and making work more efficient. Now, you might be wondering, where does the Six Sigma name come from? Well, it's actually inspired by the Greek letter sigma, which stands for standard deviation. Standard deviation is a unit for measurement of variation. The more the variation, the higher the standard deviation. Let's understand this with a simple example. Suppose we have a factory for manufacturing and packaging perfume. We have two machines and our target is to fill a bottle with 150 ml of perfume. Machine A has a 3 ml standard deviation and machine B has a 6 ml standard deviation. It's obvious that machine B will have more variation compared to machine A. Now let's understand why we aim for Six Sigma and not less than that. Take a look at the first normal distribution curve, which shows 6 standard deviations accommodated between the upper specification and the lower specification limits. Now, what if we could reduce the variation even more as shown in the second normal distribution curve and fit a total of 12 standard deviations between the upper and lower specification limits? If we compare both the curves, we find that the first curve with high standard deviation would result in 66,810 defective parts per million, whereas in the second normal distribution with less variation, we have only 3.4 defective parts per million. The story of Six Sigma is a fascinating journey that started nearly a century ago and has since evolved into a globally recognized methodology for improving processes and reducing errors. Let's break down the key milestones in the development of Six Sigma. The roots of Six Sigma can be traced back to 1924 when Walter Shewhart introduced control charts. These charts were a significant innovation in manufacturing as they allowed companies to monitor and control variations in their processes. This marked the initial step towards quality management or quality improvement. The modern Six Sigma we are familiar with today began in 1987 at Motorola when Bill Smith and his team implemented this methodology. Their primary goal was to enhance processes by reducing errors and defects. This marked a pivotal moment in the history of quality management. After witnessing the success achieved by Motorola, General Electric decided to implement Six Sigma in 1990. Under the leadership of CEO Jack Welch, General Electric played a crucial role in popularizing Six Sigma across various industries. This period marked the rapid growth and adoption of Six Sigma as a powerful tool for business improvement. In the 1990s, formal certification programs for Six Sigma professionals began to emerge. These programs provided structured training and standardized methods for practitioners, further solidifying Six Sigma's role in quality management. During the 2000s, Six Sigma began to merge with Lean principles, giving rise to Lean Six Sigma. This combination aimed to not only improve quality but also enhance efficiency within organizations. Lean Six Sigma became a comprehensive approach to process improvement. In summary, Six Sigma's journey spans from its origin with control charts in 1920s to becoming a global phenomenon in the late 20th century and evolving into Lean Six Sigma in the 21st century. In Six Sigma, we focus on four key principles that drive process improvement. Let's break them down. First one is know what's important to the customer. The first step is to understand what matters most to our customers. We identify critical to quality factors, which are the aspects of our product or service that have a direct impact on customer satisfaction. By aligning our efforts with customer needs, we can deliver better products and services. Second one is reduce defects. We aim to minimize defects in our processes. DPMO or defects per million opportunities measures how many defects occur in a million opportunities. The goal is to reduce this number as much as low, say 3.4 defects per million opportunity, to achieve higher quality and customer satisfaction. Third one is reduce variation. That is related to standard deviation. Variation in a processes can lead to inconsistencies and defects. For instance, think of manufacturing car parts. If the size of a critical component varies too much from one part to another, it can lead to defects in a final product. By reducing this variation, we can make processes more efficient, consistent, and improve quality. Fourth one is center around the target, or we can say center around the mean. We want our processes to hit the bullseye, represented by the mean. Imagine a manufacturing process for filling bottles with a specific amount of liquid. If the filling process consistently delivers the exact target amount, we are centered around the target, meeting our customer expectations. In essence, what we do in Six Sigma revolves around understanding customer needs, reducing defects, minimizing variation, and hitting the target consistently to deliver high quality products and services. Let's explore Six Sigma as a philosophy. From a philosophical perspective, we view all work as processes that can be defined, measured, analyzed, improved, and controlled. A concept often referred to as DMAIC. Processes in this context are like recipes. They require specific inputs and produce desired outputs. Here's an important idea. If you control the inputs, you can control the outputs. This concept is commonly referred or expressed as y is equal to f of x, where y represents the output and x stands for the inputs. So, what are these inputs or x factors? In Six Sigma, we recognize 6 critical inputs that can significantly impact the quality of processes. These are man, machine, material, method, measurement system, and mother nature. Man, the people involved in the process. Machine, the equipment and technology is used in the process. Material, raw materials and resources necessary for the process. Method, the specific steps and procedures followed in the process. Measurement system, the tools and methods used to measure and monitor the process. Mother nature, environmental factors, conditions, and variables that can influence the process. Now, what about the outputs or why? In Six Sigma, the outputs can be either products or services. The goal is to consistently produce high quality products or deliver excellent services by carefully monitoring, controlling and optimizing these outputs. Let's explore Six Sigma as a toolbox of techniques. Think of it like a collection of tools that help us make processes better. These tools include SPC, Statistical Process Control. SPC helps in monitoring and controlling processes by using statistical methods. It's like having a dashboard that tells us how well a process is performing. Control charts. Control charts are a visual way of tracking how a process behaves over time. They help us spot trends and variations in real time, so we can take corrective actions promptly. Failure mode and effect analysis. FMEA. FMEA is a systematic approach to identify and prioritize potential failures in a process. It's like preventive maintenance for processes, helping us anticipate and mitigate risk. Process mapping. Process mapping is about creating a visual representation of a process from start to finish. It's like drawing a roadmap that shows us where we are and where we want to go. But here's an interesting thing. Different Six Sigma experts might have their own favorite tools because there is no one size fits for all. Six Sigma gives us the flexibility to choose the right tool for the job. Let's explore Six Sigma as a methodology. This approach is like a structured and disciplined way of making processes better. There are two main methodologies within Six Sigma. First one is DMAIC. DMAIC stands for Define, Measure, Analyze, Improve and Control. It's like a roadmap for improving processes that are already in place. First, we define the problem and what we want to achieve. Then we measure the process to gather data, and afterward we analyze that data to understand its strengths and weaknesses. Next, we make improvements and implement controls to ensure the process stays on track. DMAIC is the most widely adopted and recognized Six Sigma methodology. When we are creating a brand new process, we use different approach. It's called DMAIC. Define, measure, analyze, design and verify. First, we define what we want to achieve with the new process. Then we measure the process to gather data, analyze it to ensure it meets our goals, design the process with all the improvements in mind, and finally we verify that it works as intended. In essence, Six Sigma as a methodology provides us with a structured path to follow, whether we are improving existing processes with DMAIC or designing new ones with the define, measure, analyze, design, verify, that is DMAIC approach. Let's explore Six Sigma as a quality metric in simple terms. When we talk about Six Sigma quality performance, we mean achieving an exceptionally high level of quality control, which equates to just 3.4 defects per million opportunities. But how do we arrive at this 3.4 defects per million opportunities? The first curve represents the ideal Six Sigma scenario, where we achieve an impressive 99.999996% good products with only 0.002 defective parts per million. However, in practical, long-term situations, we often consider a 1.5 sigma shift on both sides. This adjustment brings us to 99.9996% good products, which still signifies an exceptional level of quality with only 3.4 defective parts per million. In essence, these graphs highlight the difference between the ideal Six Sigma and the more commonly applied standard, both of which signify excellent levels of quality control. Let's explore the dynamic combination of Lean and Six Sigma. These two methodologies work hand in hand to achieve process excellence. Six Sigma primarily focuses on reducing process variation and enhancing process control. Think of it as ensuring that your process consistently hit the bullseye. It's about making things better by minimizing errors and variations. Lean, also known as lean manufacturing, has a different mission. It's all about streamlining operations, eliminating waste, especially non-value added activities, and promoting work standardization. Lean helps you do more with less. When these two powerhouse methodologies come together, magic happens. We get a comprehensive approach that not only improves process quality but also makes processes more efficient. It's like the perfect blend of precision and efficiency, where every step counts and waste is minimized. This combination often involves techniques like value stream mapping, which helps us visualize and optimize the entire workflow. So, while Six Sigma ensures we hit the target consistently, Lean ensures we do it with maximum efficiency. Let's explore the different levels of competence in Six Sigma, often represented by different belts. Just like in martial arts, these belts signify different levels of expertise. First level is white belt. Think of this as the beginner level. White belts are introduced to the basics of Six Sigma, understanding what it is all about. Next level is yellow belt. Yellow belts have a bit more knowledge. They understand the concepts and can assist with smaller improvement projects. Next level is green belt. Green belts are like the intermediate level. They have a deeper understanding and can lead smaller Six Sigma projects. Next level is black belt. These are the experts. Black belts are skilled in Six Sigma methodologies and can lead complex projects, making significant improvements. Next level is master black belt. Think of them as a master of Six Sigma. They mentor and train others, making sure everyone's on the right track. And next level is champion. Champions are the leaders who support and champion Six Sigma projects within an organization. They ensure the projects align with the overall goals. Now, some organizations might use more or fewer belts depending on their structure and needs. And there's also a special Six Sigma money belt, often a consultant who helps organizations save money through Six Sigma projects. In essence, these belts represent levels of competence in Six Sigma from beginners to master. Let's explore the numerous benefits of Six Sigma. First one is improved quality. Six Sigma helps you consistently deliver high quality products or services, reducing defects and errors. Next one is reduced cost. By eliminating waste and inefficiencies, Six Sigma can lead to cost savings and increased profitability. Next one is increased efficiency. Processes become more streamlined and efficient, allowing you to do more with less. Next one is data or fact-based decision making. Six Sigma relies on data and facts, ensuring that decisions are well informed and based on evidence. Next one is customer satisfaction. Improved quality and consistency lead to happier customers who receive products or services that meet their expectations. Next one is employee engagement. Six Sigma encourages employees to be part of the improvement process, leading to increased engagement and job satisfaction. Next one is risk reduction. With better control over processes, you can mitigate risk and respond effectively to challenges. Next one is standardization. Standardize processes, reduce variability and ensure consistent results. Next one is sustainability. Six Sigma helps create sustainable processes that can adapt and thrive in changing environments. In essence, Six Sigma is not just about improving one aspect of your organization. It's a holistic approach that brings a wide range of benefits from quality and efficiency to customer satisfaction and sustainability. Thank you for watching this video. I hope you found it informative and insightful. If you enjoyed this video and want to stay updated with more quality focused content, don't forget to like, share, hit the subscribe button and click on the notification bell. Your support means a lot to me and it motivates me to create more content that adds value to your quality knowledge. Thank you once again and I look forward to seeing you in the next video. Stay curious, stay quality conscious and stay connected.